Hi, my name is Joanna Benya. I am an SI tutor with the Office of Student Success, and I tutor Anatomy and Physiology 1 and 2. And this presentation is going to be over the immune system. The immune system has two parts. It is divided into the innate defenses, which are nonspecific, and adaptive defenses. Innate defenses respond immediately to defend, and they attack anything foreign. An example is sneezing, for instance. Any type of dust particle or anything pathogen foreign that goes into your respiratory tract, for instance, will automatically cause the sneezing reflex. So that's an example of innate defenses. Adaptive defenses are more specific. They do not attack immediately. They need to meet the foreign antigen first, and they have to have a specific target, and they also have memory just in case you meet that pathogen in the future to help you fight it faster. Innate defenses. Examples are surface barriers, that's the first line of defense, such as your skin and the secretions. Those ones are, of course, the first part. You have pathogens that land on you constantly, and because your skin has a pH of between 5 and 6, it's really acidic and it helps inhibit bacterial growth. Your stomach also, secretes hydrochloric acid, which has a pH of 1. Tears and saliva are also examples of surface barriers because they contain enzymes. The enzyme lysozyme, which destroys bacteria. The sebum, that's the oil, for instance, on your skin, that's toxic. And any orifices, such as like your vagina, that's a very acidic environment. And mucus in, for instance, your respiratory tract, that traps microorganisms so they can't get further into your body. Internal defenses such as cells and chemicals are also part of your innate defenses. Phagocytes, examples are macrophages. They phagocytize any foreign agent or anything in your body that doesn't have any type of your body's identifying markers. Neutrophils, those are the most abundant white blood cells, and they're also one of the first ones to attack when there is something that invades like your body, and you have, for instance, a cut, and neutrophils automatically go right away and they start a whole process of chemotaxis through diapedesis to call for the rest of your body to help defend. Natural killer cells, those are also white blood cells. Those ones go after the nucleus of a cell, acting irregular, and cause it to lysis or burst. And inflammation, that swelling, and it helps reduce the speed of the spread of any type of bacteria. And histamines, those are also, it's a chemical that's part of your body's internal defenses. Interferon, those are cells that are infected, for instance, by a virus. They will release interferon as a last attempt to protect your body. So what it does is it releases the interferon to signal to other cells that there is a virus attacking, for instance, and it will help interfere with the virus's replication. So it interferes with virus's replication, thus the name interferon. Innate defenses continued. Another example is complement proteins. Those ones, they cause opsonization, and they enhance inflammation, and they also insert the membrane attack complex. Another example of innate defenses is fever. It's basically helps inhibit the growth of microorganisms. Bacteria cannot metabolize well with rapid temperature changes, so it is part of your innate defense system until your adaptive defense systems can kick in. Adaptive defense systems. First part is humoral immunity in adaptive defense systems. That's protection from antibodies in your blood. There's two types of humoral immunity. First type is passive. That's antibodies from a different source other than yourself. There's two types of passive humoral immunity. The first one is naturally directly. That is, the mother's antibodies are transferred to the fetus, so the fetus has immunity when it's born from the mother. Artificially, that's through the injections of immune serums. So if you're poisoned, they're going to inject you with an immune serum. So that's artificial passive humoral immunity. The other type of humoral immunity is active. That is your body's own antibodies. And there's two types of active humoral immunity. Naturally, that is when you come into contact with a pathogen and you are sick, you have an infection, and so your body will develop antibodies on its own. And artificial, those are vaccines. That is when you're injected with just a little bit of pathogen, just enough for your body to recognize it, form antibodies and memory cells. So that way, if you come into contact with it later on, your body will help fight it almost immediately. Another type of adaptive defenses is the cell-mediated immunity, which is provided by T and B cells. The B cells are released from the bone marrow, and those are released directly into the blood. On B cells, there is two types of B cells. The B cells will divide, and they will form mainly plasma cells, and from plasma cells, those produce antibodies. B cells also divide when they come into contact with pathogen and will form memory cells as well, although the plasma cells are more abundant. And the memory cells will stay in your bloodstream after you are better, so that way if you come into the pathogen, in contact with the pathogen again, you will be able to fight it immediately. And another type of cell-mediated immunity is the T cells. The T cells are released from the bone marrow, but at the time that they're released, they're immature, so they're sent to the thymus to mature. In the thymus, it'll be determined what type of T cell they will become. There's three types of T cells. The first one is one of the most important because without it, your body would basically have no immune system. The helper T cells, those ones stimulate the production of other T and B cells. Helper T cells also help the plasma cells identify what antibodies to make. And they stimulate B cells to produce plasma cells to produce antibodies, of course. So basically, without the helper T cells, your B cells wouldn't be working. They also make sure that the cytotoxic cells mature and do their job, which is kill. And they release the cytokines, which cause macrophages to go into the feeding frenzy. Helper T cells also contain the CD4, which hooks into the MHC protein that is presented by a macrophage. So if a macrophage goes along and it encounters an antigen, it will eat it and present just a piece of it, so that way when it comes into contact with the helper T cell, it can show it to the helper T cell. That protein that the macrophage presents is called the MHC2 protein, and the CD4 on the helper T cell will recognize it, and it will be activated once it recognizes that. Another type of T cell is a cytotoxic T cell, also known as the killer T cells. Those ones, they have to recognize the antigen. So what that one does is your body's own cell will be infected, and it will take a piece of the antigen and present it, and the presenting thing will be the MHC1 protein. So once the cytotoxic T cell identifies it, the CD8 on the cytotoxic T cell will hook into the MHC1 protein on your body's own cell and identify it and know to attack that cell, and it basically attacks the nucleus of the pathogen and causes your own cell to lysis or burst, in other words. The third type of T cell is the regulatory T cell, or the suppressor T cells. Those ones basically suppress your immune system after you're all better and ensure that all that immune activity gets shut down. And This is just a little bit of vocabulary to help you identify and help you through in understanding the immune system. Once again, my name's Joanna. I'm an SI tutor with the Office of Student Success here at TSTC, and I tutor anatomy and physiology. Thank you.